Okay, so here we go. So in this particular function, we have two different equations. Looks like we got a trade-off at 4 here, and that'll help us to find our range and domain, so we'll keep these two guys in mind. But we can kind of think about this in two different ways. We know that if this was put on some sort of number line, right, at +4, we'll definitely have some sort of trade-off. So my first one right here, let's go ahead and do him in red. He is going to, if this was just my x line, by the way, this would be 0, he would go up to 4 here, and then he'd have a hollow dot. And then all the other x's would be in usage there. Whereas for my second equation, if I look at this line starts at 4, but it is using the 4 itself. So it'll be a solid dot, and then I'll use all the other values. So 4 is basically my switch point right here on the graph. So we'll keep that in mind as we continue to do this particular one. These are different linear lines, very basic linear lines. Negative x plus 3. We have a slope of -1. And a -1/1, however you want to think about it, and a y-intercept of 3. So if we go down to 3 here, up to 3, it's going to be right there. So there's that one. It's going to go over 1, down 1 every single time until we reach 4. So over 1, down 1, over 1, down 1, over 1, down 1, and then over 1, down 1. This is my stopping spot. So we can draw the rest of our points. If I go back one, I just got to go up one, so it's always going over 1, down 1. So there we go. This line will basically come down through here. It continues on forever upwards, and then it will go one more. But remember, when you get close to that 4, just like how this had the hollow dot there, we're going to have another hollow dot right there, and it's going to reach that point. Now, for our next line, it's x minus 4. So this one would start at -4 right there. I'd go up 1 over 1, up 1 over 1, up 1 over 1, and so it would actually start right here. Because remember, it switches off at 4, and if we look right here, it's the solid dot at 4. And then if I continue to go up 1 over 1, it'll just fill out the rest of these problems. And right there is this linear piecewise function. Pretty easy if we know what we're doing, what we're talking about. The hardest part for almost everyone is just the switch. Just remember, and this is what I'll say, once you know where it's going to break, and here's my break line right here, you know that this first graph will go in the first section, because these are almost always sequentially ordered, and this second graph will go on this side. So as long as you know that, you'll normally be fine. Now let's talk domain and range here. For our domain, which are our x values, since all of the left are included and all of the right are included, the only problem we might have is 4, but if you notice, we do have a solid dot on 4, so it's just going to be all real numbers. All real numbers. Whereas the range, on the other hand, becomes an issue. Now, we notice that these are going upwards, and they go upwards forever, so we know everything above this is going to be included. So we can say that y, which is my range, has to be greater than. Now, I would normally say greater than or equal to, but this dot is hollow, so technically won't reach that point. If it won't reach it from there, it won't reach it from there, but we can go just a slight bit back, and if you notice, we're basically already into it there. Obviously, if we were to zoom in, it would be very different than what we see here, but y is going to be greater than 1. It's greater than everything above. It fills out. Sorry, -1, not 1. So there's my domain, there's my range, there's my graph. This problem is actually finished. Okay, so here we have another one. We got a couple absolute value graphs. And if you just don't forget, absolute value graphs make these wonderful V sort of situations. So we'll probably have some problems going on there. But another thing that I want to point out is that these graphs are also very similar in a lot of ways, but it also is split up into three different parts. So let's look at the split here and see what's going on. So I have my first split comes at -1, which is right here. So there's my first split. So this first graph will fill out all of that space. Whereas my second flip ends at 3. So second one will basically go right in here, and the last one will fall into the third section. So there's my three graphs in the three different sections. We just have to fulfill the requirements in each of these different sections. Now this time we're going to do this a little bit differently. This time we're actually going to make an XY table because we have an absolute value sort of idea going on. Now we will use 3, -1, and 3 twice, just so we can kind of see what's happening. But we'll go back a little bit. Let's start this at -4. So if I take the absolute value of -4, which is 4, minus 4, that's 0. And if I go -3, I'll be at -1, and -2, obviously -2, and so forth and so forth till we get to -1, which it actually is never going to get to -1. And this is kind of a very difficult to understand topic, but just remember there are billions upon billions of little decimal places right in between -2 and -1. Matter of fact, there's technically an infinite number of numbers between those numbers, which is a little bit difficult to understand. But we're going to say that we're going to basically get to -1. But we're not going to get to -1. We're going to say that it's slightly small. So we'll put a small negative, say, hey, we're not quite to -1. We're a little bit smaller than -1. So it's like -0.9999. Or sorry, actually, no, -1.000 type of an idea, right? Because it's slightly smaller. I always go the wrong direction for some reason. But I put a -1 in there, and I put this symbol here for a couple of reasons. Basically, you can do all sorts of things. You can put an H, as in this is going to be whole, or it's a hollow dot, however you want to think about it. There's a lot of way people mark this. Just find out what works for you. I like just small marks because I already know kind of what's going on. And so it doesn't really bother me too much. But anyway, if I do a -1 here, absolute value -1 is 1, 1 minus 4 is -3. So I can graph those points there. So at -4, I'm at 0, and then it just looks like it's going over 1, down 1. Technically, it would flip, and we're going to leave a little hollow dot right there. It would flip at the end there, but in this particular case, it's not going to. So there we go. There's all the rest of my dots, so I can just complete this particular graph. Connect my dots, and I'm finished with this one. Now let's go ahead and start our next equation. This equation's finished, so now it's time to start this one. The great news about this one is once I do -1 again for my new graph, it's going to be -3. Now the interesting thing is if we notice these 2 points are exactly the same. So how do we show that? We actually show this as if it never stopped. We're going to fill in that dot right there. And if you notice, it's always going to be 3 going all the way across till we hit a hollow dot right here at +3. Matter of fact, if we put a +3 right there, and we can put a hollow dot. And this is a slightly smaller than 3 in this particular case. We're still going to be at -3 because it's never changing. This is just constant, so it just goes straight across. That's it for that one. That one is particularly easy, so we'll cross that one out. Finally, we got the last one here. Gosh, let's use pink. Why not? This is just an absolute value graph. Very classic. X is greater than 3. So we are just going to start here at +3 for our last one. So if I put a +3 in here, the absolute value of +3 is just 3. So this time we are going to see a bit of a break in our graph. A discontinuity is what it's called. And so we're going to shoot up here. Obviously, we don't stay at -3, -3, -3, and then all of a sudden jump up to +3 in most things. So there's big sudden difference or big sudden change, but we can keep going. If you do 4, then you're at 4, and if you notice, it's just going over 1, up 1, like so. the last one, last absolute value graph, if you notice, was going over 1, down 1. Now, there's a chance that, of course, this graph could have a vertice, sorry, not a vertice, a vertex. So as this graph continued to go down, if I had continued to draw this graph, it would have hit there and then it would have flipped directions and started going back up like this. But it didn't, because in this particular case, it just won't. So if you also notice, there's a difference between the pink graph and the black graph that we had before. The pink graph is up above the black graph, and if you notice, the distance between these 2 points is always going to be related to this 4. There's always going to be 4 spaces between these 2 graphs if I had drawn them exactly in the same for the same graph. But obviously, since it's piecewise, we just take the different pieces and put them together. But this would be the answer for this. So let's go ahead and let's label my domain and my range. Now for domain. Domain is once again be all real numbers, whereas the range is going to be far different than that. Range is going to occur, all the numbers up above are used. If you notice, this is going up forever, this is going up forever, so all those are going to be used. So obviously y is going to be greater than something. So we look for our bottom sort of rung of the ladder here, and if you notice, this guy right here creates the bottom. He's just kind of a little bottom shelf there. So y is always greater than -3, and this particular problem is finished. We've created all 3 graphs, we've graphed them appropriately, we've stated our domain and our range, we're done. So that was pretty nice. So we've now got our next graph here. Sketch graph, obviously we're going to find our domain and range yet again. So let's go ahead and we'll take these apart piece by piece. So first of all, we've noticed that our change is going to be at this +2. And if we look at these 2 graphs, this one we just saw another absolute value going on here. But if we look at the top graph, we got a squared value, and when you square an x, that makes a quadratic. So we got 2 different things going on, but we'll still be able to graph it just the same. So we'll start with a quadratic. We'll make ourselves a wonderful little XY table here. And let's go ahead and since this looks like it moves to the, let's see, right 2 units, right? So this is actually going to be interesting. So yeah, right 2 units. So my vertex would normally be at the 2, and in this particular case, it's going to be at the 2 as well. So we'll actually put the 2 down, then we'll go 1, 0, -1, and let's all go all the way back to -2. So let's start by putting a -2 in there. -2 minus 2 is a -4. -4 squared is a +16, so quite large, actually. This one will actually be 9. Because that'll be 3 squared, -3 squared. -2 squared is a +4. So this is the first time we see it. At 0, we end up at here at this +4. Everything before that was off the chart, so it was all up there. But we're going to start seeing this more. At +1, we will just be 1, and at 2, we'll be at 0. So +1, you're just 1, and at 2, you're at 0. And this is a fill dot since we have the less than or equal to symbol. So there we go. There's the quadratic. Pretty easy, especially since we didn't have to worry about where the vertex is or anything like that. We already knew where it was going to end, so we just made the graph in accordance to what we already had. So now we're going to go ahead and we're going to take this red one right here, just an absolute value. We got a negative absolute value. So that means that normal absolute value would go like this, but if you stick a negative sign out in front of the x, then it basically is just going to flip from a valley to a mountain. So we're going to be dealing with a mountain type equation. Now it's just negative x, so we'll just continue on, but we'll start at 2. Remember, this 2 comes after this guy, so he's going to be slightly larger than 2. But the absolute value of 2 is 2, and then it becomes negative, so this is just -2. So at 2, we're at -2 hollow dot. Remember, you can put the h, you can do whatever you want to remember, But there you go. And then after that, there's no outsiding information, so this just becomes a over 1, down 1 sort of linear graph. We've already passed the vertex. The vertex would have been at 0 when we would have seen the other side, but since that side is out of this graph, this is all that we see. Now, this one's interesting. And it's interesting for a lot of reasons. The domain is going to once again be all the real numbers. However, the range is a far different and unique problem. And the reason why is because we have this split here. So in other words, everything is included except for the span between 0 and -2. But 0 would be included, so not 0 and -2. So the question becomes, how do we represent that? And this is a unique idea here. It basically goes as follows. Y can be greater than 0 or equal to, greater than or equal to 0. And or y can be less than -2. So we got two different rules here. It's either bigger than 0 or less than -2. And that will involve all our items. And as we can continue to get on the year, I'll show you how to do proper notation for this. But for now, that's what you really need to kind of understand there. Y is bigger than 0 or less than -2. And we'll start going over unions and joining things, but that's for a later moment. Okay, so this is our last problem here. We obviously have it split into 3 different parts yet again. So our split is here at -3. We also have another split at +2. This guy has both the solid dots, while these two will have empty hollow dots. So this one's actually really easy. If I am less than -3, I am at 2. So I put a hollow dot right here because this is where the graph basically ends, right? It comes up to this point and stops. But everything else is always 2. Since there's no x value causing you to go up and down, left or right, do any sort of weird things, and it is just a straight to the left problem. So that's very convenient for us. Makes the problem slightly more easy, or not more easy, slightly easier. So let's look at number 2 here. Now this, I'm going to rewrite this as -x² + 4 because it's easier to see. So I know that this is going to go through the y line at +4. That's also going to be its vertex. It's not going to move left or right because it doesn't have a b value. It's got an a value of -1 and a c value of +4. But since there's no b value, then nothing else matters. Matter of fact, we can even build this off here. So let's go ahead and make an XY table for this so we can make it properly. So we know at 0 we are at +4. So we'll do a -1, a -2, and obviously the -3. We'll do the +1 and +2. And this 4, since 4 is going to be at the vertex, since it didn't have a b value, or it's not in vertex form, which would have moved us left or could have moved us left or right, I should say, then we know that the vertex is at 0. So that's great. So let's go ahead and let's put a 1 in there. If I put a 1 squared, that's just 1, but it becomes negative, making this a 3 at 1. If I put a -1 in there, you get the same thing because -1 squared is +1, but it becomes negative. So -1 + 4, you got the same thing. And that's going to be repeated throughout. If I put a 2 in there, that's -4 + 4, making this a 0. And this would also then be a 0. The only odd man out is this -3, which would create a -9. That gives me a -5 in this case. So that's great because that now gives us a point in which we can draw right here. At -3, -5, we got it. -2, 0. -1, +3. +1, +3. +2, 0. Interesting. Oh my goodness. Draw properly, please. So hard to do. Rather be doing this at school where I'm better at it. So anyway, there we go. There's that one. Now there's just one particular equation left that starts. I've already used this color. I don't care, brown. Starts at this positive 2, and that's x minus 3. So we're going to run 2 again, just kind of see where we're at, but it is going to be a hollow dot, so it's going to be a slightly larger 2, so we don't get those two mixed up because this is a different line. So if I have 2 minus 3, that is negative 1, highest it can ever be. So at 2, I'm at a hollow negative 1. If I go to 3, this is just going to go over 1, up 1. So at 3, we'll be at 0. And this will continue. 4 is at 1, so forth, so forth. So then we just connect the connector line like that. And there we go. That's 4 for you. End of the problem. We can see the two hollow dots. I did label this one. I didn't do this one because it was just a single. It was just 2 all the way across, but I did put in my 2 hollow dots. I put in everything else. So let's talk domain and range. Once again, domain, everything works. So all real numbers. Whereas range is a problem. So obviously this line that's going upwards will basically use all the numbers going up. So this guy right here is my lowest point that it can ever get, which is at negative 5. So y is greater than or equal to, since that's a solid dot this time, negative 5. There we go. So there we go. If you have any more questions about this, feel free to ask. But yeah, I'll get this sent out to you guys so that you guys can watch it.